Today we're going to be conducting 4 experiments. First we're going to start with some static balloon experiments, then we're going to move on to our rolling can experiment, then we'll make a static flyer, and finally we'll finish with a homemade electrophorus. Hi everybody, I'm Paul from the Reddick Public Library. You might know me from Libratory, our weekly hands-on science program at the library. Thank you for tuning in for this, our 6th ever online science video. Today we're going to be exploring the amazing science of static electricity. We're going to be looking at conductors, insulators, plasma, and we'll experiment with different household materials, and we'll even make our own electrophorus, which is a fancy word for something that allows us to manipulate static electricity. While most of our experiments rely on balloons and pie tins, please be careful and get adult supervision if you handle a compact fluorescent light bulb or a plasma ball. Okay, let's get started. For this series of experiments, you'll need 2 balloons, your hair, string, scissors, 1 glass cup, tissue paper, styrofoam, a metal spoon, and any other objects you might want to test. Okay, for our first series of experiments, we're going to be experimenting with some balloons. So I don't know if you've ever experienced this, but sometimes if you get a balloon and you rub it on your head, you can create some static electricity and make your hair stand up, right? So what we're going to do in this first experiment is we're going to get a balloon and we're going to rub it against our head, and we're going to create a charge on that balloon. Luckily, I have a balloon right here. Okay, so you might want to set up your own balloon hanging from your ceiling somehow with some string like this. All right, so for this part, it's very scientific. I'm going to rub it right on my head. Let's test all of our materials with a static charge on them as well. All right, so I've got a nice static charge on this balloon. Let's see what it does. Let's move on to our glass. Bear with me as I rub a glass on my head. Yep, it is attractive. So let's move on to our tissue paper. Okay, let's see. Yep. And it has so much static now that it's actually just sticking right to it. Okay, now I'm going to rub some styrofoam on my head. Oh, seems like it's repelling. Yep. Now let's try a spoon. Okay. Whoa, yep. It likes that. Okay, let's see. Yep, it likes that too. Very much. Okay, so what we're noticing here is that the metals and myself definitely seem to attract the balloon, but the other balloon that we had that had the negative charge seemed to repel it. So what just happened? These experiments are all about static electricity. Static electricity is the buildup of an electrical charge in an object. Sometimes static electricity can suddenly discharge, like when a bolt of lightning flashes through the sky. Other times static can cause objects to cling to each other, like socks from the dryer. Static electricity involves negatively charged particles, known as electrons, jumping to positively charged objects. Rubbing the balloon into your hair adds electrons to the balloon, and it takes electrons away from your hair, which causes the balloon to become negatively charged. When 2 objects are rubbed together, the transfer of electrons goes from the least electron-loving material to the most electron-loving material. The negative charge that rests on the balloon's surface is known as static electricity. The charge rests on the surface because rubber is an insulator, meaning it doesn't conduct the flow of electricity well. Other materials conduct the flow of electricity better and are known as conductors. Different types of materials have different affinities for electrons. By rubbing a variety of materials against each other and testing their interactions, the tested materials can be ordered according to their attraction for electrons. Scientists call such an ordering of substances a triboelectric series. Okay, so that about does it for our static balloon experiments. What we're going to do now is move on to our next experiment. For this experiment, you'll need 1 balloon, the hair on your head, 1 aluminum can, a hard flat surface, and any other objects you'd like to roll. All right, so here we have a balloon and we have some cans. For this experiment, we're going to see if we can make any of these cans move with just using our balloon. So our can is made out of aluminum, which is a metal, not exactly the same as the metal that was in our spoon or in our stapler, but do you think that it'll act similarly? Let's add some static electricity to this balloon. Okay, so I've put the can in the middle of the table here, and let's see if it is pulled or pushed. Ready? Whoa! Let's try it with some of our other cans. Okay, let's try this last one. So yeah, you could do some can races, whatever you like. So what just happened? In this experiment, we observed the negatively charged electrons resting as a static charge on the surface of a balloon, which attract the positively charged protons in the aluminum can. Opposite charges attract. The excess electrons on the balloon attract the protons in the aluminum can. For this experiment, you'll need one balloon, the hair in your head, or a fabric like wool, one plastic bag, and scissors. Okay, so for this you're going to need to get a plastic bag. You could use a sandwich baggie, or you could use a plastic bag like this, whatever you like. So what you're going to need to do is cut vertically so that you can create a nice O-shaped piece of plastic once you've cut it. Okay, so here what I've done is I've cut off a piece of that plastic bag, and it's a nice circular shape. This is what's going to become our static flyer. Okay, so what we're going to do next is we're going to rub this piece of plastic on our hair or on some wool or some other fabric so that we can get some of those electrons off, and that's going to allow us to create a negative charge. And we're going to do the same thing on our balloon, or if you wanted, you could use a piece of PVC or a plastic bat, something like that, which is going to be what's going to allow us to make this float in the air. So I'm going to try it right now. Okay, do the same thing with the balloon. So it takes some skill, clearly. I'm not great at this, but you also can do it with a piece of PVC or a bat, a plastic bat. So this could be a fun activity to do outdoors if you wanted to make your static flyer fly outside. You could make different designs. You could make an octopus or some other kind of design. So what just happened? In this experiment, we observed the negatively charged electrons resting as a static charge on the surface of the balloon, repelling the negatively charged electrons that are on the plastic baggie. Like charges repel. All right, so now we're ready for our next experiment. For this experiment, you'll need one aluminum pie tin, one styrofoam plate, one styrofoam cup, your hand, one plastic straw, masking tape, aluminum foil, string, scissors, one compact fluorescent light bulb, wool, and other fabrics to test. Okay, so now we're ready to move on to make our electrophorus, which is actually something that will allow us to observe static electricity in action. Okay, so hopefully you've assembled some of your materials. You need your pie tin, you're going to need your styrofoam plate, aluminum foil, some tape, and some string. And also we're going to be using a styrofoam cup, or since I don't have a styrofoam cup, I'm going to be using half of a styrofoam egg crate. That's going to be my vertical portion, and a straw. Okay, so the first step to making this is we're going to take our pie tin, and we're going to take our styrofoam cup, or I have half of a styrofoam egg carton, which is going to be the vertical portion that we need to put, and we're going to tape it to the bottom using this masking tape. Okay, so now I've got my electrophorus, which has a pie tin, and it has my nice vertical section, which is made out of an egg crate, and it's all taped into it very securely. All right, so the first thing we're going to do is we're going to add a static charge to the bottom plate here by rubbing this wool hat onto it. So you want to make sure to get your styrofoam plate, and then we're going to rub it with a hat. Okay, so you're going to rub it for maybe 30 seconds, 40 seconds, okay? All right, so if I were to touch it right now, I would actually get a little shock. Yep. I don't know if you heard that, but there was a little bit of a jolt that just came through. So now that I've given that shock to my finger, there's an interesting thing that's happened. So if I were to just take this and hold it, that styrofoam plate's going to stick to the bottom now. So that's pretty cool. And that's because of static electricity. Now, what's also cool is that if I were to take this styrofoam plate off, and then I were to touch my finger to the side of this, I will get another shock. Yep, I just heard it. Did you hear it? If I put it back down, I can touch it again and get another shock. Yep. So you could do this repeatedly.
See, that's sticking again. You've already done it. And then if I take it off, there you go. I got another shock. You can keep doing that and transferring that shock back and forth. So you can see visually this is sticking to the bottom of the plate using static electricity. But you can't really see the spark too well. You can't really see the shock too well. Even though I'm saying it's happening, it's hard to really see it. You can hear it a little bit. So what I'm going to try next is I'm going to put the lights down, and I'm actually going to take one of these compact fluorescent bulbs, and I'm going to see if I can get it to light up. So first what I'm going to do before I do this is I'm going to fully charge this plate again with our wool hat. Okay, so I know it's kind of dark and it's hard to see, but what I've done is turn the lights off so we can see this a little better, hopefully. So what I'm going to do now is pull away this plate. Okay, so now I've taken away the bottom plate, and I'm going to see if I can get this light bulb to light, or show a spark, hopefully. Let's see. Do you see that? It did light. Show it up close again. There you go. You're not going to be able to see the static actually jumping in this lighting, but it is happening and you can feel it if you put your finger up to it. So it's kind of a cool sensation. You can actually keep doing it. So right now the charge, if I take away this plate, I can get a shock. There you go. If I put it down, I can get a shock. If I lift it back up, I can put my finger up to it and get another shock. Yep.
So what just happened? In this experiment, the styrofoam plate is an insulator. When we rub it with the wool cloth, we transfer electrons from the wool cloth onto the top of the styrofoam plate. Because it is an insulator, the electrons do not move. When we place the aluminum pan, which is a conductor of electricity, onto the top of the styrofoam plate, the electrons in the aluminum pan move towards the top of the pan, and the positive ions move towards the bottom of the pan. If you bring something like your finger or the light bulb close to the pan, the negatively charged electrons will flow out through your finger and down through the ground, which is the little shock you feel. When you then lift the pie tin up from the styrofoam plate, the electrons on the styrofoam plate will stay where they are, and the positive ions within the aluminum pan will become evenly distributed. Since the aluminum pan then has a net positive charge, if you bring your finger near it again, electrons will pass from your finger to the aluminum pan to return the aluminum pan to an overall neutral charge.
So now that we have seen the actual physical attraction of these plates together with static, and we've also seen the transfer of static charge from this tin to the light bulb, let's move on to the next phase of this experiment where we can actually see a little bit of physical movement. Okay, so what you're going to need for this part is a straw, and you're going to need some string, and you're also going to need some tin foil. Okay? So what you're going to want to do is get about a 3 centimeter by 3 centimeter piece of tin foil, a little square, and you're going to actually take a piece of string, and then you're going to tie that string to your straw, and I'm just going to tape it in place. So what I've done is I've actually taken my string, and I've taped it to the end of this straw, and then I've knotted a little knot at the end of this string, and then I put a little bit of tin foil around it. Okay, so this is then going to be attached to the rest of our electrophorus, and this is going to be what's going to show movement. So what you're going to want to do is punch a little hole through the side of your styrofoam cup or egg crate. Okay, which I've already done here. And you want to line it up so that the tin foil ball hangs just right to the edge of your electrophorus. You want it to go right to the edge. Okay, so you might need to adjust your string length possibly to get it to be just right, but you want it to look something like this. So what we're going to do is put another charge onto this, and we're going to see if we can get this ball to move. I'll take my wool hat, and I'm going to rub it for another 40 seconds. So I've fully charged this plate. I'm going to put it on top and see what happens. So it may not look like a lot from over there, but there is actually a little bit of distance between the ball and the side of the tin. There's actually an electrostatic charge which is preventing those from really touching. So if I touched this plate right now, it would discharge that charge. Okay. So it's been discharged and now it can go right up against the plate. But what if I take away this plate at the bottom? What will happen then? Something that's important to remember with this project is that when you're taking these apart, you're going to need to only touch the styrofoam portion because that's insulated. If you were to touch the tin directly, you're going to transfer whatever static charge is in there right to you. So what I'm going to do right now is I'm going to separate these two. Okay. And when I separated them, you might have noticed that the tin ball came away from the tin again. Okay. So now I want to show you something kind of cool. There's a negative charge on both the tin and the ball, so they both would want to come towards my finger. So this ball should come towards my finger, discharge its charge, and then be sent back to the tin to collect another charge, which will then send it away from it because it doesn't want to be near the same charge towards my finger, and that's going to discharge on my finger again. So then it's going to keep going back and forth and back and forth and back and forth. And it doesn't sound like it's going to happen, but check it out. Okay, I just did the same thing again, and we'll see if we can get it to move a little bit more. So I know it's far away, but you can see that I've charged the plate, and now this ball is away from the plate again. So if I were to put my finger near it, it's going to want to go near it. Oh, there we go. And then if I were to lift it, it goes back away. And I can do the same thing over. Alright, so we've successfully made an electrophorus and we've transferred our static electricity back and forth many times. So you could try this with many different materials. Right here I've got wool, which has worked pretty well. You could also use polyester, you could use different acrylics. I have acrylics. I even have alpaca. So if you really wanted to make this into a full experiment, you could try all of these different fabrics. And what you could try to do is measure how far away from the side of this the ball gets. Now this is a very rough design here, so I'm not sure that we would really be able to measure it too easily. But scientists do use electrophoruses, not quite like this, but more scientific versions that can measure different static charges of different materials. So it's pretty cool. All right, let's learn a little bit about plasma balls. So here we have a plasma ball. It's one of those rare things that allows us to see electricity in action. It's really cool because what you can do is you can actually touch it and the little tendrils will go to your fingers.
So how does a plasma dome work? Well, a plasma ball has a central Tesla coil which produces a high voltage alternating current of electricity. It also has a glass dome which contains low pressure noble gases such as neon, argon, xenon, or krypton. A typical gas atom contains an equal number of both positive and negative charges. The positive charges in the nucleus are surrounded by an equal number of negatively charged electrons, so each atom is electrically neutral. The central Tesla coil emits a high-energy radio wave which causes electrons to move very fast, which then causes the noble gases to ionize. When they ionize, they separate into unstable positive nuclei and negative electrons. This creates plasma. Plasma is the fourth state of matter. The other three being solid, liquid, and gas, of course. Plasma is a gas that has received so much energy that it has been torn apart into charged particles. While plasma seems unusual to us, most of the universe is plasma. It is estimated that 99.9% of the universe is plasma. On Earth, you may notice plasma in a neon sign, a plasma screen TV, fluorescent lights, an aurora in the sky, or when you see lightning. In the universe, our sun, other stars, and various nebula are examples of plasma. Nebula are where stars are born. The streams of light you see are caused due to the differences between the high-energy inner dome and the lower-energy outer dome. The electrons jump outward. While moving outward, electrons are being lost and gained by the noble gases, which release photons of light in beautiful colors. When you touch the glass, you give the electrons a quicker path to the ground than going through the air, which is why when you touch the orb, the electrons go towards your fingers. The energy field actually continues beyond the dome, so if you put a compact fluorescent bulb near the dome, you will see it light up. You might also be wondering about lightning. What makes lightning? Lightning is also an electric current which heats up gas molecules to create plasma. To make this electric current, you need a cloud. Clouds form as warm air rises, heated by the ground. As the air rises, pressures and temperatures decrease to below freezing and the water vapor turns into ice. Soon this cloud becomes a thundercloud as small bits of ice bump into each other. All these collisions create a buildup of electrical charge. Eventually, the whole cloud fills with electrical charges. The lighter, positively charged particles rise to the top of the cloud, and the heavier, negatively charged particles sink to the bottom of the cloud. When the positive and negative charges grow large enough, a giant spark, lightning, occurs between the two charges within the cloud, or between the cloud and the ground, to neutralize the charge. Lightning making its way to the ground looks for the quickest route, which is why tall buildings like skyscrapers or even shorter buildings like barns have lightning rods on the top to direct the flow of lightning strikes in a safe way. Lightning is like nature's IMAX version of static electricity, creating the beautiful and awe-inspiring sparks that you see.
All right, well, thank you for joining me. I hope you had some fun learning about static electricity today. And I hope you had some fun learning about conductors, insulators, plasma, and making your own homemade electrophorus. Anyway, keep testing all your different materials and let me know if you find a different material that works much better because we would love to hear about it. All right, bye. Not very good at this. Oh gosh.